Hello and welcome. This is Organic Chemistry 2, where we're looking at review part 2, focusing on the acidity of carboxylic acids. Carboxylic acids contain a carbonyl group and an OH. That hydrogen is quite acidic, so you can lose that hydrogen. We will say that strong acids will easily donate the hydrogen, while weak acids will not donate it easily. So we use something called pKa value. So low pKa means strong acid. Carboxylic acids have pKa of about 4, while alcohols have pKa of about 15. So you can see carboxylic acids are stronger acids than alcohols. Now when that proton is lost, you end up with a carboxylate ion where that oxygen now has a minus charge. And this carboxylate ion is stabilized by resonance. To show resonance, we draw a resonance arrow. The arrowhead is facing both sides, and that means resonance. And what's going to happen is that the minus charge on this oxygen, electrons will flow to form a double bond between oxygen and carbon, and then the other double bond electrons will flow to oxygen to become a minus charge on that oxygen, and now you have a double bond on that oxygen. So because we have two resonance structures that represent this carboxylate ion, it makes the carboxylate ion quite stable. Alcohols, on the other hand, when they lose a proton, they become what's called alkoxide ion. And alkoxide ions are not as stable as carboxylate ions because they're not stabilized by resonance. Now let's compare the acidity of different carboxylic acids, A, B, C, and D. Remember, when we say acidity, we are looking at the ability to lose the carboxylic acid proton. When you compare the electronegativities, fluorine is the most electronegative element in the periodic table. So when you go down the group 7A, next will be chlorine, next will be bromine, and next will be iodine. So that means fluorine is the most electronegative, and because it's the most electronegative, it attaches strongly to bonding electrons. That means it's very hard to break the carbon-fluorine bond because fluorine is the most electronegative, and therefore that bond is going to be very strong. On the other hand, it's going to be very easy to break the carbon-iodine bond, so that's easy to break. So because fluorine is the most electronegative, that means it's going to withdraw the electron density really strongly, while iodine will withdraw the electron density weakly. So it won't be as strong as fluorine. So they are on opposite ends of the spectrum. Now remember what happens. When you lose a proton, you get a minus charge, a carboxylate ion, which has a negative charge on oxygen. So you have a developing negative charge on the intermediate. And having fluorine, which strongly withdraws electron density, will help stabilize the developing negative charge on that oxygen, as opposed to iodine, which is a weak withdrawing group, and therefore the developing negative charge is not as stabilized. And because of that, you end up with this being more stable. The carboxylate ion of this compound C, it forms a more stable intermediate, then it's more likely to lose a proton, and therefore we say that is the most acidic. So C would be the most acidic, C greater than, then the next one is chlorine, so A greater than, next one is bromine, which is B, and then the last one is D.